All right, students, I think by this topic, I would conclude this chapter. Change of state, actually, these are bracketed term. Change of state was our ultimate topic, constant temperature, process, latent heat. These two topics also involve in the change of state topic. Here I'm only considering water and ice. Water freezes at 0 degrees Celsius. Ice melts at 0 degrees Celsius. So at 0 degrees Celsius, it is difficult to answer. What happens? Actually, both things are possible. Water boils at 100 degrees Celsius. Water gets converted into vapor at 100 degrees Celsius. So once again, there's a question that at 100 degrees Celsius, is it water or vapor? So here I want to tell you that whenever we heat something, its temperature increases. So if I would have a piece of ice and I am heating it, if I'm talking about ice, you people only think about 0 degrees Celsius, but ice can be below that also. So let us suppose this ice piece, anyhow, I have made it at minus 10 degrees Celsius. I think there is no doubt in anyone's mind that how ice can be at minus 10 degrees Celsius. Actually, ice freezes, ice formed at 0 degrees Celsius, and if we lower the temperature, no problem. It can still be ice. Anyway, now if I am heating it, its temperature will increase. And I am heating it uniformly from all around. So first its temperature would increase. It would become minus 5. Actually, negative, it is an increase. Then it would become 0. But at 0, still it is ice. Now what happens? If we are heating it uniformly, it turns into liquid. But still it is 0 degrees Celsius. So what is happening? If we are applying heat, its temperature is increasing. Here its temperature is not increasing, yet we are supplying heat to it. Here heat, here also we are supplying heat. So why this time temperature didn't increase? And most importantly, why this transition take place at 0 degrees Celsius, at same degree, at same temperature? It is because here the heat supplied is increasing its temperature, but here the supplied heat does this state transformation. This supplied heat making it liquid from solid. It means supplied heat can increase the temperature or it can cause the change in state, which is happening here. Now state changed due to the supply of heat. In the same way, if I would have some water, I have placed it in a small dish, in a small bowl, liquid, and I am freezing it. Freezing it, in other word, we can say that I am extracting its energy from it, extracting its heat from it. In simple word, we are freezing it. Now what will happen? Let us suppose this is at 10 degrees Celsius. So first, its temperature, oh, don't think that its size decreased. Actually, it is just the drawing error. It is still that much amount. Now it is minus 5 degrees Celsius. Then it will become water at 0 degrees Celsius. And if we further cool down it, it will turn into ice. This is now ice at 0 degree Celsius. So now what is happening? If we are cooling it, we are withdrawing heat from it. So if withdrawing heat from it or taking heat away from it, its temperature decreases, and that withdrawing heat causes change in state. So we can say that solid, here I am just focusing on ice. It turns into liquid by plus heat, by adding heat, and it turns into solid by withdrawing heat. So the heat which causes state transformation is called latent heat. Actually, today my video is not properly working, so you might have some problem in it. Oh God. All right, so there comes a term called latent heat. So I'm just stating it. It is the heat energy required to change the state of a substance. In the same way, there is another term called specific latent heat. And in the same way, there is another term called specific latent heat. It is the amount of heat required to change the state of unit mass of substance is called specific latent heat. Latent heat is just the heat required to change the state. Specific latent heat is the heat required per unit mass. Latent heat, its measuring is its SI unit is joule, which is used for energy, and its common unit and CGS unit, CGS as well as a common unit is calorie. CL, calorie, and its bigger CGS unit is kilocalorie. Oh, I forgot. 1 calorie is equal to 4.2 joule. Remember these relations. Specific latent heat, its SI unit is joule per kg because it is for unit mass. Upon means energy upon mass. That is why energy upon mass. For CGS, it is calorie per gram or kilocalorie per gram. It can be kilocalorie per kg also, although it is not CGS, but sometimes they take this thing also. So latent heat is a hidden heat which is not observing, which we are unable to observe actually. So what is happening, like here, if I'm supplying heat here, I can observe it by change in temperature, by observing change in temperature here also, but here temperature remains same. So a hidden kind of heat is there. It is absorbing heat, and that is why without changing temperature it is turning into liquid. That is why if you have ever heard in the hilly regions, people often say that they do not feel so much cold when it occurs snowfall, but when snow melts, then they feel much colder. It is why because that snow during its melting, it absorbs heat from the atmosphere, and that is why cool down the atmosphere and gets converted into liquid. So that is why during snowfall it doesn't feel much colder than when it is melting. And in the same way, you have often heard that during snowfall most of the people are roaming around, they are not feeling much colder. It is because during snowfall or just before snowfall, water is getting converted into ice. So it is actually withdrawing heat from it. Water droplets present in the atmosphere are withdrawing heat from themselves, and that heat goes into atmosphere and we feel bit warmth. But they are losing their heat and getting converted into snow. So that is why during snowfall or just before snowfall, it is not much colder than during the melting of snow. All right. So what happens actually? Actually, ice is much colder. Ice is melting of ice is much colder. That is why during melting it feels colder. So actually, the specific latent heat of melting of ice is very, very high. So specific latent heat, its symbol is L. For vaporization, its value is 540 calorie per gram. That is, when 1 gram water gets converted into 1 gram vapor, it requires 540 calories. On the other hand, latent specific heat or specific latent heat of freezing is equal to 80 calorie per gram. That is, to convert 1 gram water into ice, it requires 80 calorie heat to withdraw from it. And vice versa also. If we want to convert 1 gram vapor, steam, into water, we have to withdraw this much amount of heat from it. And for melting, we need to add this much amount of heat into 1 gram of water. So now, as earlier I told you about freezing and melting by giving you an example of snowfall. So also in vaporization, what happens actually, it would be so sad if you would ever get some burning of hot water. So may God, no one of you can face such problem ever. But it is very painful and very inflammation would there if someone burns with hot water. But hot water at 100 degrees Celsius would not produce so much severeness than its steam, because that steam has this much heat with its 1 gram. So 1 gram of water is a very small amount and it's produce so much amount of heat. That is why be careful while handling boiling water, while making tea, while boiling milk. Otherwise, these steam would produce severe damage. Here, I would just tell you that if someone gets these accidentally come contact with vapors, steam, so to prevent it, you have ice. Just apply ice to it. Most people would just argue that by putting ice on that exposed area which is exposed to steam cause blister, what can I say, uh, blister, like it is our skin and that skin bump out by filling some liquid in it. So it happens, but that's not a big problem. Actually, applying ice would reduce that severeness of steam burn. Well, that is other discussion. But still, I will just suggest you people always have some ice in your ice box of your refrigerators, because such kind of incidents or accidents can happen anytime. So anyway, just move on to next thing, that once again I summarize. Latent heat, heat required to change the state, specific latent heat, heat required to change the state of unit mass. For vaporization, high, very high latent specific heat. For freezing, still it is high. That is why for freezing, this much amount of heat should be removed, or to melt, this much amount of heat should be added at 0 degrees Celsius. Same happens with vaporization. Now, it is an incomplete study. Actually, here I have written that water freezes at 0 degrees Celsius. Here, one more thing. Both of these points are there because at atmospheric pressure, it happens at atmospheric pressure, all right, which has very large value, very large value, about this much, 1 lakh Pascal, very much high pressure. So it is our atmospheric pressure, and at this atmospheric pressure, these things happen. It means if atmospheric pressure would change, or if we devise something which, if we create something where we vary atmospheric pressure of a machine, we have placed water inside it, and if we are applying pressure to it, or we have put ice into it and we are applying pressure to it, so it might, these points might change. I mean, then water would freeze at a different temperature. Same happens with boiling water. It also, this 100 degrees Celsius is at this atmospheric pressure. Now, an interesting fact. In the hilly regions, atmospheric pressure is little lesser. Just remember this thing. Hilly region, atmospheric pressure is lesser. And what happens? Due to this, boiling point of water also decreases. Quite interesting fact. It goes around 80 to 90 degrees Celsius. It doesn't boil at 100 degrees Celsius. Now, an interesting fact is also there. A pressure cooker. What happens inside a pressure cooker? Pressure inside the pressure cooker increases. This is a pressure cooker. This substance to eat aloo. All right. Okay. So what happens when we heat it? So steam creates here lots of pressure. Pressure increases. Pressure increases, and it increases enough that it crosses the pressure of atmosphere. So it becomes about twice of atmosphere. Approximately, more or less can be there. And due to this increase in pressure, boiling point also increases. Now water doesn't boil at 100 degrees Celsius, but 120 to 140 degrees Celsius. And as water is now boiling at this temperature, now think about it. In the hilly region, if we are boiling water, or we are cooking this potato in an open vessel, I'm not using this pressure cooker, and I'm boiling it, and water starts boiling at 80 degrees Celsius. So this temperature will never change, because now it is this change of state is taking place, which takes place at a constant temperature. It is taking place at 80 degrees Celsius. So this potato will receive this 80 degrees Celsius temperature, and now it will be cooked by taking too long time. But here in a pressure cooker, as water is boiling at 140 degrees Celsius, so more and more heat is getting into the potato, it will be cooked earlier. Quite interesting. So students, now just go through some more information about these high specific heat. So student, when we apply pressure, when here, when we increase pressure, boiling point also increases in the same way. All right, but what about melting point? Try it by yourself. And I have given you earlier an activity to take ice, two ice cubes, let one of the ice cube to melt of its own, and other ice, press it with wood or by placing some clothes on it, so that your body heat would not get transferred into that ice piece, and observe how fast it is melting or how late it is melting. So it is just for you. You need to find the answer of this. Anyway, the conclusion is change in state would require some energy changes also, heat energy changes. So for melting or vaporization, it requires heat, and for freezing or for liquefaction, it requires withdrawal of heat. All right, and these are some terms: latent heat, specific latent heat, I told you earlier. So now go through all of these information, and what can be the use of such high specific latent heat of vaporization and such high specific heat of freezing in our daily life. Find out. Try to search it in through internet. All right, find it out, and don't think that it is 540, it is 80, it is very much lesser. It is also very large amount of heat. All right, so think about it, and just I'm concluding this chapter. This is all of it. Okay, and if you people have any doubt, still any doubt in this chapter, you can send your messages, and tomorrow we will do a doubt session for it. Bye bye.